All right, today we're trying a brand new type of filament, PETG. It's from HQA, which unfortunately HQA decided to stop making filament, but I'm going to use this anyway. And it'll help me printing other types of PET filament. So this is silver. The reel is 200 millimeters across and about 75, 78 millimeters wide. And PET is more sturdy filament than PLA. It can handle higher temperatures and it's stronger, but it has to be printed at a higher temperature. So in this case it says 230 to 250. Now the Flashforge NX can only go up to 240, so hopefully we can print somewhere between 230 and 240. So when we do our temperature tower, we're going to use those temperatures. And the bed temperature says 35 plus or minus up to 60. So for that we're going to try 40 degrees C to start off with. So this is a 1 kilogram reel, and I'm hoping this works out with this printer. Is one reason I got this printer, because if you want to make some objects that are more sturdy and hand up to more abuse, then you want to make it out of PET. So. All right, so here we are in OpenSCAD, and we've got our temperature tower. Now, two things different about this than we've done before is one, it says PET down there because we're using PET filament, and the other thing is we're going by 2 degrees for each bridge this time. From what I've read, you don't really want to print PET at low temperatures. It's just going to clog everything up. So we don't want to go below the recommended temperature, which is 230, and we don't want to go above the maximum temperature of our printhead, which is 240. So we're just going to go from 230 to 240. Actually, we'll go 240 down to 230 every 2 degrees, and we'll see how the temperature profile does. And so that's that. And then we imported it over into Simplify 3D. Here it is. And we had to set up a new temperature profile. So this is our HQA PET profile. And the temperature, the bed temperature, we're going to start at 40. See if that works. And here's our temperatures. So because again we don't want any clogging, we're going to start the base at 240, and then we're going to go down to 230 in increments of 2 degrees. So that's what these are doing here. Okay, so that's all good, and we'll say prepare to print, and it's going to take 1 hour and 4 minutes. So we'll switch over to the time lapse. All right, so we're going to load the filament, and we're going to set the preheat temperature. That's what the filament load function uses. So we're going to set it to 240. That's the maximum. Just hopefully it'll load better. And I set the bed temperature at 40 for now. We're going to test that later, but we'll start out with 40. So now I'm going to go to load filament. Oops, load. All right, so now it's going to heat up to 240, and that'll take a few minutes. So I'm going to show you a couple other things. So we're using our side loader as usual for the big reels, and it feeds through, and then I want to keep this white feed tube behind this black cable bundle here. Just everything works better if you do that. It's going into the top of the print head, and we're using this short tube to help keep erosion from happening around the print head there. All right, so we'll come back when it's loading and we'll see how it works. It's trying to feed, but it's not going in. I wonder if we have to unclog the print head. That would be a pain. Alright, we're going to stop this to unclog the print head and try it again. Alright, when I unloaded the previous filament, it looks like it snapped off. That's why it wasn't loading. So that's unfortunate. Not sure what I did differently there, but in this case a little bit sticking out. So this time we're going to heat up the print head, and then we're going to pull on it to try to pull it out instead of trying to push it in. Then once we're done with that, we'll push in the rest. Now it's heated up. We're going to go ahead and pull on this. Ready it to come out. Alright, got it out. I think that's going to be it. We can go ahead and push the rod in here, but I think there's not going to be much coming out. Yeah, some's coming out. That's good. Okay, so we got a little bit more out of there. So now hopefully the POA or the PET will feed properly. So I'll bundle this back up and we'll try again. Alright, it's heated up, it's starting to feed, that's good. Some should start coming out in a second. Looks like it's feeding smoothly. With popping sounds. Let's see it come out. Here it comes. Alright, so there's a little bit of gold left from the previous print. And there's our silver. Alright, so that's good. We're ready to do our temperature tower now. Alright, it's done. So we'll get it off the platform. And came up pretty easily, but it was sticking okay. So let's look at this temperature tower. So there's drooping on all of them, which is not great. Yeah, there's some string on 226, so I'm going to have to say 236, I guess. I have to say that 240 is all we're going to get out of this one, so that's okay. I think for what we're going to use it for, this side doesn't look too great either. So hopefully 240 is enough to get some good use out of this, because that's our maximum. So. Alright, well, we'll print out some other stuff and see how it comes out. That's 240 and 40 degree C bed temperature. Alright, rather than do a separate bed adhesion test, since it looks like it adhered to the bed fine, I'm just going to go ahead and do this all in one test. We're going to be doing lots of different prints with this PET, hopefully. Maybe it doesn't do bridging very well, but there's other things we can do. So we will just go ahead and print this out. And I set up a profile for the PET, so it's HQA PET. And the temperature is 40 degrees for the bed and 240 for the extruder. So we'll say prepare to print. And it's going to take 3 hours and 35 minutes. All right, so we'll send it over to the printer and switch to the time lapse. Alright, it's done. Let's see how we did. I'll move it up a little bit. The printing on the front looks pretty good. That's that indented printing. And this is embossed printing. This looks okay until it got to the top, and it didn't do that well. The bed adhesion is good. Sticking to the bed well, let's get rid of that. We didn't get any separation over here like we got on this one. This is really the best one we did. You can see this side was tipping up because we didn't have a high enough bed temperature. Let's get it all the way off and look at the bottom. When it was laying down the first layer, it looked like it was doing a really good job of it. So. It's coming out pretty easily, unlike some other stuff. So the bottom layer looks pristine. Look at that. It looks really good. I said this looks good. These overhangs did okay for a while, then they started having problems. They got too steep. The tower tests broke off, which has been a problem. It's not some of the other POAs. These cylinder tests worked pretty well. The bridging test, as we suspected, didn't do very well. Lots of stringing, lots of sagging. These indentation tests are fine. The printing didn't come out. I'm not sure I set the parameters correctly for the printing to come out. I'll have to look at that. And this is a support test. That looks okay. And then these solids, anything solid like this front part, anything solid looks really good. Anything with a lot of like overhangs or things that are small, like these small pillars, that's just not enough strength in there. So, but anything with a reasonable dimension printed pretty well. So it's gonna be good for some things. I just broke that off. Oh well. So again, we compare it to this. This is the best print we did of the all-in-one print. The ABS print had a bunch of problems, so because we did this over and over again until it came out right. In fact, I fixed the printing and so forth. So these towers did break off, but they're pretty flimsy. And the bridging did really well on this one. And again, the bridging on here looks terrible. So. I did find out that there are some tricks to printing with PET that we didn't really try yet. Like I think one of them is printing slower. So I think what we're going to do is, this is not the worst result. For some things, obviously, this wouldn't be very good, but the first part of this overhang, these indented letters, look pretty good. So it did better on the fine details than I expected based on the temperature test. But in any case, we're going to go back to the temperature tower and try some of these other methods of printing with PET and see if we can improve our results. Because remember, the temperature tower looked pretty bad. So here's the front. The front doesn't look bad. There's a lot of stringing over here, but 240 is okay. The indented letters here doesn't come out too great, but on the back it looks terrible. So we're going to see this is a lot faster to print than this, obviously. So we're not going to do this again, at least not right away. If we see some big improvements here, maybe I'll try this again and see if it comes out better. But the main thing we want to do is try to improve the printing of this thing, and maybe some other simpler prints, using some of the techniques that are out there for printing with PET. Didn't get any clogging issues, so I think this printer can print PET at 240. We'll just see if we can improve the quality of the results by tweaking some of the other parameters that are available in Simplified 3D. So that's the plan. We'll see how it turns out. If you like this video, please give it a thumbs up. Post a comment if you have any questions or ideas, and I'll try to respond. That's all for now, but more videos are coming, and if you want to see them, please subscribe to my channel and turn on the notification icon if you don't want to miss one. This is Beta Signy signing out, and keep looking up.